$6 million. That is what China spends to build 1 mile of highway. America spends $50 million on the same mile, same asphalt, same concrete, same steel. China builds it for $6 million, America builds it for $50 million, and the $44 million gap between those two numbers is the subject of this video. The answer most people give is cheap labor. That answer is wrong. Strip out every labor cost from a Chinese highway mile and replace it with full American union wages, and the price moves from $6 million to $6,800,000. Not $50 million. The gap lives somewhere else entirely, and almost no one is looking at where. This is the channel that follows the money in global construction. Subscribe and drop a comment. What do you think drives American infrastructure costs? In 1956, Dwight Eisenhower signed the Federal Aid Highway Act and authorized the construction of 41,000 miles of interstate. The system was funded through a dedicated federal fuel tax and built under a procurement model that had been standard in American public construction since the New Deal. Competitive bidding, independent contractors, separate contracts for design, environmental review, earthworks, paving, and signage. The model was transparent, it was accountable. It was designed to prevent the corruption that had plagued government construction projects in the early 20th century. It also locked in a cost structure that was never designed to be efficient. It was designed to be auditable. Those are not the same thing. That procurement model is the original sin of American highway construction, not the engineers, not the materials, not the unions, the contracting architecture. Here is what that architecture looks like at full deployment. A standard American interstate expansion project in a suburban corridor involves an average of 47 separate federal, state, and local approval processes. The environmental impact statement alone averages 4.5 years from initiation to approval. The direct administrative cost of regulatory compliance, including legal review, environmental consultants, public hearing administration, and documentation, averages $9 million per mile before a single piece of equipment touches the ground. That $9 million does not move 1 cubic yard of earth. It produces paper. China spent the equivalent of $180,000 per mile on regulatory compliance for its national expressway network. The difference is 32 times. Not because China has no environmental standards, because China's 2004 National Expressway Network Plan issued corridor-level authorizations covering thousands of kilometers at once, rather than reviewing each project individually. 3 cost categories explain where the remaining gap lives. None of them are the ones that appear in most infrastructure debates. The first is land. In the United States, land is private property. The Fifth Amendment requires the government to pay fair market value for any land it takes for public use. On a suburban highway corridor, the kind where most new American capacity is being added, land acquisition averages $12 million per mile. In active urban zones, that figure reaches $30 million before the first survey stake is in the ground. In China, all land is state-owned. Individuals hold long-term use rights, not title. When the government designates a highway corridor, it does not purchase the land, it reallocates it. Average land cost per Chinese highway mile is approximately $400,000. That single legal difference, a constitutional provision protecting private property against government taking, accounts for $11.5 million of the $44 million gap before any construction activity begins. To understand what land acquisition actually looks like at the project level, consider the expansion of Interstate 405 in Los Angeles, completed in 2014. The project added a single carpool lane in each direction along a 10-mile corridor through the Sepulveda Pass. The total cost was $1.1 billion, $110 million per mile for a lane addition, not a new highway. Approximately 40% of that cost was land acquisition and utility relocation. Property owners along the corridor received compensation packages negotiated individually over a period of 6 years. Several contested their valuations in court. The litigation added 14 months to the project timeline and approximately $80 million in legal and administrative costs. In China, the equivalent corridor expansion would have been designated, cleared, and under construction within 12 months. The landowners would have been compensated at administratively determined rates with limited appeal rights. Whether those rates were fair by market standards is a separate question. They were processed at a speed that the American system structurally cannot match. The second is supply chain structure. A standard American highway project contracts separately for geotechnical survey, design, earthworks, drainage, concrete supply, asphalt production, paving, signage, electrical, and landscaping. Each contractor carries its own overhead, its own profit margin, its own bonding requirements, and its own mobilization costs. The combined markup layer on a U.S. highway project averages 22% of total construction cost. For every $100 that enters the project budget, $22 go to the administrative structure of contracting before a cubic yard of concrete is poured. China's major state-owned construction groups own the cement plants, the rebar mills, and the asphalt batching equipment. Production facilities are positioned within 3 to 5 kilometers of the active construction front. One organization, one budget, one mobilization. Independent analysis of a Guizhou mountain expressway quantified this effect directly. Vertical integration reduced material and logistics cost per mile by $8.3 million compared to equivalent fragmented contracting. The third cost category does not appear in the construction budget at all. It appears in the design standard document. Chinese expressways are designed for a 20-year service life before major structural rehabilitation. American interstates are designed for 40 years. That single specification difference changes the required thickness of every structural layer below the road surface. Thinner base courses, different subgrade treatment, reduced bridge deck reinforcement on lower traffic corridors. The result is an estimated $6 to $9 million in reduced material volume per mile across the network. Added up, land $11.5 million, regulatory compliance $8.8 million, supply chain markup $8.3 million, design life specification $7 million. That is $35.5 million of the $44 million gap, accounted for by 4 systemic decisions that have nothing to do with the wages of the people pouring the concrete. China did not build cheaper roads by paying workers less. It built cheaper roads by owning the land, consolidating the supply chain, streamlining the approvals, and engineering for a shorter design life it had already planned to replace with rail. That last point is the one that stops people mid-sentence when they actually process it. China designed its expressways to last 20 years because it already knew that by year 25, the primary freight movement across China would have shifted from truck to high-speed rail. Building a road to a 40-year standard would have meant overbuilding for a use pattern that would not exist by the time the road reached the middle of its designed life. The expressway was not the destination. It was the transition infrastructure for the decade it would take to build the thing that would make it redundant. China built the road knowing it was temporary. The United States builds roads as if they are permanent and then watches them deteriorate because the maintenance funding was never secured. Here is what happens when a country builds permanent roads without a permanent funding mechanism. The American Society of Civil Engineers gives the U.S. road network a D+ rating in its most recent infrastructure report card. Not because the roads were poorly built, because the Highway Trust Fund, the dedicated revenue source established alongside the interstate system in 1956, has been structurally insolvent since 2008. The fund is financed by a federal fuel tax of 18.5 cents per gallon that has not been raised since 1993. In inflation-adjusted terms, the revenue the fund collects per mile driven has fallen by approximately 40% since the tax was last updated. Electric vehicles, which pay no fuel tax, represent a growing share of the vehicle fleet. The gap between what the fund collects and what maintaining the existing network costs is currently estimated at approximately $190 billion per decade. Congress has been filling that gap with general fund transfers since 2008, which means the interstate highway system is no longer funded by its dedicated revenue source. It is funded by deficit spending on a rolling basis, with no long-term maintenance plan attached to that spending. China's expressway network is primarily funded through tolls. The tolling system generates revenue in direct proportion to usage, which means the funding mechanism scales automatically with traffic growth. It also means that the cost of the road is borne by the people who use it rather than distributed across the general tax base. This is not inherently fairer. Toll roads are regressive by definition, but they are self-sustaining in a way that a fuel tax whose real value erodes with inflation is not. Three things look different now than they did at the start of this video. The first, the $44 million gap is not a construction cost problem. It is a governance cost problem. The actual act of building a road, moving earth, pouring concrete, laying asphalt is not dramatically more expensive in America than in China once labor costs are normalized. What is dramatically more expensive is the system of approvals, land acquisition, and contracting structure required before the building can begin. The United States is not paying for infrastructure. It is paying for the bureaucracy required to permit infrastructure. The second, the Chinese design life decision was not a shortcut. It was a strategic choice that only makes sense if you have already planned the next infrastructure layer that will replace it. America's 40-year design standard assumes you do not know what the infrastructure landscape will look like in 40 years, and therefore must build for permanence. China's 20-year standard assumes you do know and builds accordingly. Both assumptions reflect a different theory of planning. One of them requires a 40-year national infrastructure plan to be coherent. The other is reactive by design, which means it is always catching up to the infrastructure it should have built a decade earlier. The third, every reform proposal for American infrastructure costs focuses on the construction phase. Faster permitting, modular construction, prefabrication. These are real improvements with real savings. None of them address the land acquisition cost, which is constitutionally protected. None of them address the fragmented contracting structure, which is legally mandated to prevent corruption. None of them address the Highway Trust Fund solvency problem, which is a political problem masquerading as a technical one. The gap will narrow. It will not close. Because the remaining gap is not inefficiency, it is the cost of a governance system built around a specific set of priorities, and those priorities are not going away. China's expressway network hit 177,000 kilometers in 2023, making it the largest in the world. The United States interstate system covers 78,000 kilometers. The American system is older, better maintained on a per-mile basis, and built to a higher structural standard. It is also not growing at a rate that matches its own traffic projections, not being maintained at a level that matches its own deterioration rate, and not funded by a mechanism that can sustain it through the next 20 years without structural reform. The engineers who surveyed the first Chinese expressway alignment in 1987 retired before the 100,000th kilometer opened. They were already surveying the high-speed rail corridors that would eventually make the expressways secondary. The road was never the point.